Hi, my name is AndresAlvarez, and I'm going to be talking about the qualitative analysis of potential binding of ligands to FKBP12. FKBP12 is a relatively small protein that induces the degradation of other proteins through a process called ubiquitination. This is helpful because it can be used to degrade oncogenic proteins as well as misfolded proteins that can cause things like Creutzfeldt-Jakob disease. Only 10% of the protein can be targeted, so that very severely limits what FKBP12 can bind to and degrade given its current state. However, we're trying to circumvent that using a process called the small molecule assisted receptor targeting, the SMART pathway. This pathway involves using a ligand bridge shown over there on the right side. So you have fluorescein and folic acid, which are your two ligands, and then you have your two receptors on each of those cells. In this case, we would use FKBP12 and the target protein that it needs to degrade. That ligand bridge would just each side would bind to its corresponding receptor, bringing those two proteins together and causing that degradation. So this catalysis by approximation, it allows for a much more modular targeting of proteins because you can just easily swap out the receptor and the ligand. So in order to test this, we needed to figure out what ligands actually bind to FKBP12, what ligands are best in different scenarios, that type of thing. So we did a small molecule microarray. Small molecule microarray allows you to test a lot of different ligands at once. It allows you to test up to 10,000. We only tested 8,335 in this experiment, and out of those, we only found 15 actual hits. That's very few, but that's to be expected. So out of those 15, we chose two that were likely to be of note for us because ligand 28 and ligand 18 both have 8 rotatable bonds, meaning that they can conform their structure very easily, very well. They can fit their structure to bind FKBP12 better than maybe other proteins might. However, our results show that ligand 28 bound to FKBP12, while ligand 18 did not. However, these results were statistically insignificant. They showed a p-value of 0.1, so they weren't that far off, but they weren't statistically significant in this experiment. Our PPIase assays proved to be inconclusive considering our blank had protein in it, so that threw off the results, and that would have to be redone. So using the 15 binders we found in the SMN, we would want to move forward with that procedure, trying to figure out the binding characteristics, the binding affinity of those ligands, how those respond to different factors in the environment, how those change from a test tube to physiological conditions, that type of thing, so that we can progress forward and move into potentially finding a pathway that can be used to target different oncogenic proteins in humans. Thank you.